Hello girls, today we are going to discuss about binary tree traversal in detail. So this is also one of the most important topic related to trees. So from this topic you may have a question like pre-order, post-order and in-order traversal, write about them in detail, or any one traversal, or they may give a problem and ask you to write a traversal for it, binary tree structure for it. Let's now try to understand what traversal is and how you travel through a binary tree. So traversal is a frequently used operation. So when it comes to trees, traversal is the most important and also frequently used operation, right? So what actually traversal means? See, traversal means yeah. So traversal of a tree means stepping through the nodes of a tree by means of the connections between parents and children. So it's like if you want to reach a destination, for example, I want to go to Secunderabad railway station or MGBS bus stand, right? So there are so many routes from the place where I am to that particular destination. So I can take any of the routes. Like if I take the route through uh, Amirpet and Panjauta, Khairabad, that is one route, and the other way I can go via High Tech City, Gachibowli, High Tech City, Mehdipatnam, Lakdi Kapul, and that's other route. Okay, so there are so many ways to reach one particular destination. But here, when you start from your route, you can reach, when you want to reach a particular child uh, at the lowest level of the tree, you have to move through several other nodes. You have to pass on through several other nodes by means of the connections, right? So that is what traversal is. So traversal of a tree means stepping through the nodes of a tree by means of the connections between parents and children. So you can also call it as walking the tree, and you can call the action as walk of the tree, right? So traversal can be called as walking the tree, and that walking of along the tree is called walk of the tree. So traversal means visiting every node of a binary tree. So in the traversal, you will not leave any node. You have to visit each and every node of the tree. That is what is traversal. So you have to completely visit the all the nodes of the tree in one or the other order. So depending on the order how you visit each node will decide what type of traversal it is and what kind of traversal it is. Okay, so the operations generally you perform on tree are searching for a particular node, which for example some data is stored at that node and you want to retrieve that data. So first you have to search for the node where the data is located. Next, print some information and also insert a new node into the tree or delete a node, like that. Okay, so these are all the operations that you generally perform on a tree. So for all these operations to carry out, you need a traversal, because to search for a particular node you have to go through the whole tree to locate where the node is. So that is what is actually traversal is, right? So what this operation is nothing but traversal is used to visit each node exactly once. So in this walking through the nodes of the tree, which is called traversal, you will be visiting each node exactly once. They are neither repeated or they are not left, without visiting. So they are visited exactly once. A full traversal of a tree visits the nodes of a tree in a certain linear fashion. If you visit it repeatedly, if you visit a node for the second time, actually it will form a path or circuit, which will contradict with the definition of the tree. So that is the reason we are saying that The traversal is nothing but visiting the nodes of the tree in a linear order, in a linear fashion. So this linear order will be familiar and as well as useful when it comes to arithmetic expressions. So when you want to express arithmetic expression like a plus b plus c, or a plus b into c, or a plus b by c, in this way, when you want to represent an arithmetic expression or store an arithmetic expression into your uh, memory, this kind of representation by using these trees will be very much helpful. And this expression will be having three notations like infix, postfix, and prefix. So depending on the type of traversal, the kind of traversal, it will give rise to these three notations: infix, postfix, and prefix. Right, let's see what they are. This will result in three traversals: in order, post order, pre-order traversals. Okay, in order traversal will give you infix notation, post order traversal will give you postfix notation, and pre-order traversal will give you prefix notation. Okay, so what are the three various ways that in which you can travel through the tree? So first one is yeah, here we are saying that symmetric traversal. What is symmetric traversal? The way in which you visit the node, root, it's a children, left subchild and right subchild, or left subtree or right subtree, are to be visited in the same fashion. Then only you can there will be what is called uniformity. You can tell in which particular path or which particular sequence or route you have followed. If you go through the notes, it won't give rise to any particular sequence or useful or reliable answer, right? So that is the reason you have a symmetric traversal is the best way to travel through the each node. That is the how you treat the parent node and children, that subtrees also should be treated in the same manner. See, if L, D, and R stand for moving left, data, and moving right, let's see how the 6 combinations are given rise to. So how these 6 combinations will come into picture. See, L, D, R. So I am starting from left. L, D, R. Right. Next L, R, D. L, R, D. So I am visiting left node, next right node, and next data. Next DLR, first root node, next left, next right. Next DRL, root node, right, next then left. Next RDL, reverse. RDL. Next RLD, RLD. So these are the 6 possible combinations in which in the form you can visit the trees, in the way which you can visit the trees. Right, now let's see this expression tree, arithmetic expression tree. If you carry out these kind of traversals like moving left, then data, then right, so all these 6 possible combinations, if we apply on this tree, what are the possible outcomes? That is, what are the possible 6 traversals? See, L, D, R, always you have to visit the left node first, next data node, next right node. So we apply that here: left, data, right. So 5, okay, next minus, okay, next 6, next comes plus, right? Next again you have to go to the left node, 3 into slash 3 into, next you have to come to 8 because you have to move to the left node, then only you will come to the right node. Okay, 8 slash then 4. So this is what is always moving to the left node, then data node, then right node. Left node, data node, right node. Left node, data node, then right node. Because nowhere you have to revisit or a node for twice, for second time, right? So that is the reason we have to visit always the left node first, next data node, and next right node. Okay, so this is what is left data, right traversal will result in. Next, left right data. So left 5, right 6, data minus. Next, 3, 8, 4, slash, then x, then plus. Okay, so always you will have to visit left data first, next right, and then data. Left, left, then right. If there is no where to go in the left, then you will jump to right node. So right, next you come back to data here, next you come back to data here, next you come back to data here. So data will be coming in the last. Next, DLR. So DLR, so data first, next left, and then right. So DLR. Okay, DLR, right. For this, sorry, for any particular node you have to visit its left first. So for this is the root, so for this it is left, right? For this it is the left, so you have to visit 5. So DL, for this DL, okay, 5. Next you will go to R, okay, fine. Next you come back to right here, for this it is right, so into, next left, okay, next for this it is, again you come back here, it is right slash left and right. So D L R. So D L, if there is left child, again you have to apply DLR. So D, already we have listed, L R. So here it's finished. So you will come back here, right, D L. So for here again you are having a right child, so again for this D L and R. Okay, so this is how your DLR will be. In the same manner DRL, so you just go through, you apply this traversal here, the order in which you have to travel. DRL, first D, next R, next L. Okay, so first D R, always R till you reach, till there is no left to go, then L, next 3, next here you will give minus, get minus, next left, next right, next you will get left, at the last you will get the L. In the same manner RDL, and now next RLD. So by seeing all these 6 traversals, you can come to a conclusion that LDR, say LDR and RDL are mirror symmetric and reverse order. So this is in one order, I mean towards, all the elements are towards right, I mean, and the sorry, in this you have just reverse of it, mirror symmetric. See here also LRD and DRL. See here, just opposite of it, 5 6 minus 3 8 4 slash into plus, here same reverse, plus into minus 4 8 3 minus 6. Okay, so these two are also mirror symmetry, DLR and RLD. So by this you can come to a conclusion that only 3 traversals are taken into consideration. In whatever way you traverse, they will give you symmetric and mirror symmetric paths, traversals. So that is what we are seeing here. So when we take that, when we have to consider 3, take out some conclusion of these traversals, you can say that LDR, LRD and DLR are 3 traversals which give you the correct way in which you have to go through or walk through the tree. So these are called in order, post order and pre-order traversals. What are they called? In order, post order and pre-order. So in order will give rise to infix, post order will give to postfix, pre-order will give rise to prefix arithmetic expressions, right? So this is about your binary tree traversal. So the first one is pre-order traversal. So what is pre-order traversal? So in this traversal, the route is visited first, next followed by left subtree, and then the right subtree. So first the route is visited, then followed by left subtree and followed by right subtree. In left subtree also again you have to follow the pre-order notation only, that is visit the left first, then right, then route, and then right. Okay, so yes, and next then for right subtree also you have to follow the pre-order notation only. So first, what is the pre-order traversal? Visit the route first, next traverse the left subtree in pre-order, next travel the right subtree in pre-order, right? So let's see the, so this is the algorithm for pre-orders. This is what you have to write, and you have to give an example of the traversal, or you may get a problem like this and ask you to write the pre-order or post-order traversal of that particular tree. Okay, so if you understand what this is, you can write for a pre-order or post-order traversal for any tree which is given to you. So in this, for this particular diagram, let's see what the pre-order traversal is. So according to our definition, first visit the root A, next left subtree B. Again in this subtree you have to follow pre-order. So again you have to visit the left subtree. Then you have to go to right. Okay, there is no further left here, so you will go to right. Okay, so there are no nodes to move on here next. So then you will come to the right subtree of the root C, and then you will come to the left subtree, right? So always you have to follow this order. First visit the root, then move to the left, left, left. If there is no movement, or I mean there is no other node on the left side present to move, then you will move to the right, and then you will come back to the right subtree. Okay, so this is what is your pre-order traversal is. So this is what is the sequence we can come to when you traverse this through this tree in pre-order. So this is the expression. So plus into A, B, T. So this is what pre-order traversal is. So this is prefix expression, when all the what you say operators are used first and then the operands. Okay, so this is what is your pre-order traversal. So 1, 2, 3. In simple you can represent it like this also. First visit the data, next visit left, next visit right. So this is what you have to keep in mind. Visit a node, traverse left, and continue moving. When you cannot continue, move right and begin again. When you cannot continue there also, move back until you move right and stop. There is no further node to. Always you have to move left, left, left. If there is nothing there, move right. Again you come. If that tree is finished, get back. Go on to the right subtree. There also you apply the same thing. Move left, left. Nothing there. And move further. Move right. Okay. So this is about your in pre-order or in order traversal. This is one more example. So you just once apply this algorithm here, and if you have any doubts then ask me. Okay, right? So pre-order traversal is also called as depth first traversal. This is what you have to keep in mind. So pre-order traversal can be called as depth first traversal, other name for it. Next, in order traversal. So what is in order traversal? So in this traversal, the left subtree is visited first and followed by the root, and then the right subtree in order. In the same manner, left subtree is visited first, In that also each subtree should also be visited in order. Next, when all the left subtree is completed, you will visit the root and go to the right subtree. And there also you have to follow in order: left, left, root and right. Okay, so traverse the left subtree of the root node in order. Next, visit the root node. Next, traverse the right subtree of the root node in order. See, if you go through this same tree in order, what will be the expression? So this one will be the expression D, B, E, G, A, F, C. So see here, D, B, E, G. So all the traversal is done. Next you will revisit root. So A. Again you have to go to left first. You can't go to right here. So left. So F, then C. Okay. So this is how you will traverse in order traversal. You walk in order traversal. Same thing can be applied for this also. You once apply the same rule for this binary tree and generate the expression. So that should be equal to this. Yeah. The in-order function simply calls for moving down the tree towards left and until it no longer can proceed. Okay, so next visit the node, move one node to the right and continue again. So this in-order traversal is the other name for this in-order traversal is nothing but symmetric traversal. So for pre-order traversal it is called depth first traversal. In-order traversal it is called symmetric traversal. So this is the pictorial representation or graphical representation, whatever you call, for this in order traversal. So you have to keep these 3 points in mind when you traverse through the tree in order. Next is post order. What is post order? In this traversal, the left subtree is visited first in post order, followed by the right subtree in post order, and then root. So here the main difference is left subtree is visited as it is. Okay. Next, followed by right subtree. Here it is in the middle, you are going to root, right? But here you will not visit the root. You will move the right subtree in post order and then you will go to the root. In last, you will go to the root. In pre-order, you will first visit the root, then left and then right. In order, you will visit the left subtree, then root node, then right subtree. In post order, first left subtree, then right subtree, and then you visit the root node. Okay. So what is the expression that you generate when you traverse through this tree in post order? See, D, B, E, D, G, E, B, F, C, A. D, G, E, B. Next you come to right subtree. F, C. Then last you will visit A. So first you will go to left. Then you will go to the right subtree. So D, G, E, B. Then you will come to its root. Then you will come to its root. Then you come to right. Again you will go to left first. Then right. There is no right here. So you will go to the root and go to the root and visit the root node of the tree in the last. So that is the expression that you get when you traverse in the post order fashion. See what post order traversal is. Traverse left and continue again. When you cannot move right and begin again, okay, move to the right and go back. And if you can't move further, if you can't move further, move back until you can move right and visit the node. Visit the root node. When you reach the root node in the last, it is the end of the traversal. So this is the program code, implementation for the traversal in the program. This is what we are seeing how it happens. The traversal is happening in a diagrammatic form or pictorial representation. The program form is this binary tree, post order. You will pass on a note to it. If root is not equal to null, you will apply this. It is as it is a recursive. You are writing it as a recursive method. You will call the same what you say method itself. So post order, root to left child, again post order, root to right child, and finally you will read the root that where the data is located, right? So this is all about your traversals, post order, pre-order and in-order traversals, which are the most important topic in your trees topic, most important ones in your trees topic. So you should be able to write the expressions when the question is asked, like when an expression tree is given like this, and you are asked to write a expression for it, generate an expression from this tree, then you should be able to write like this kind of expression, prefix or postfix or infix expression. Or they may give you an expression and ask you to write a tree for it, but both vice versa can be asked. So uh, listen to this class thoroughly, and if you have any doubts, ping me in the group. In the next class I will start applications of binary tree. Have a nice day. Take care. Bye.